Thank you for your introduction. I wanted to make the presentation a little bit simpler. I have about 10 slides, so 20 minutes means that I'll spend 3 minutes a slide or something like that. And I'd like to say that, the world is getting flat. You might have heard of an author called Tom Friedman. So he's saying the world is flat. What's happening here in Japan could affect California in 1 millisecond, okay? And it could then propagate all the way to Europe. So as I came here last night from San Francisco, and then I woke up this morning and we talked to our customers, in the US, and we talked to some customers in Texas, in Indiana, and in Pennsylvania. So I was in a hotel this morning in Tokyo. So what we talked about actually would have a major impact in the United States. So what Thomas Friedman is saying is indeed true. What we're doing in Japan is going to affect, worldwide. So instead of saying Cloud Computing Day Tokyo, I would say Cloud Computing Day Tokyo and globally. Okay, so maybe the next time you can change the name to be global. So my topic today is the AI solution for telecom industry. And as you know that from previous presenters, the KDDI presenter, Mr. Tsukishima-san, he talked about KDDI solution for a bunch of problems for the communication service and other business they have. And I feel this is a resonance, with me, because what I'm working on is to help the telecom industry. And my main subject here today is the AI solution as it applied to the carriers, the telecom industry, to manage, the overwhelming number of devices. So if you look at the devices, let me go to this slide. So you can see right now globally there are about 2 billion plus, handsets serviced by the carriers. And then by market study, for the IoT, it's going to be 10 billion devices. And all these, handsets or the IoTs, and not to mention there's another category of products, it's called M2M, okay, machine to machine. And these are all the monitors that are installed in the Coke machine or in the distribution center that monitors the shipping or the purchase of the devices by the consumers. And so the M2M market actually is very, very big. And then those 3 major categories of product are going to overwhelm the telecom industry. And so we, as a technology software company, we try to use the AI solution to reduce the impact or make it more feasible to manage the devices. Since I came from the Silicon Valley, I can tell you, AI is becoming a most hot, topic, because we are in Sunnyvale and we are on a street where we are surrounded by Apple. The right and the left and the front and the back are all Apple buildings. And then not far from where we are, there is an Apple car division that's in a building. And we can see the AI application for the auto industry. I think this was already discussed by other speakers. So we personally could see the Google cars, the autonomous driving cars in the neighborhood. And it's a car that has a sensor mounted on the top. And then there are other, cars that are equipped with, like 8 different sensors, like Tesla. as an example. So in our neighborhood, we're seeing more Tesla cars than any other place. And as you can see, there are 8 monitors on the Tesla. Each one is equipped with GPU. It's got an AI capability. And you can drive a Tesla, and when you're trying to park a car, go through a parallel parking, you can just press a button. The car will back up and it will go into the parking space. So that is a demonstration of the AI, in the car industry. And not too far from where we are in Palo Alto, you have Ford, you have General Motors, you have Mercedes-Benz, you have BMW. They all have AI labs in Silicon Valley. So this is another example of the AI being so popular. And the other thing is the healthcare. And I think there was some discussion about healthcare. And as you know that for healthcare, they are talking about using AI to replace the doctors, okay? So in fact, in Carnegie Mellon, a research center, the director actually made a statement saying, in a few years, there will be very few doctors because AI is so popular, so powerful rather. And he actually shown an example where the AI diagnostic technique could predict or diagnose diabetes more accurately than the doctors. So you can see the impact of the AI coming to everywhere. Okay. In terms of the main subject that I'm going to be talking about here is about the device management in the telecom industry, where you need to manage, billions of handsets that are being processed, purchased, returned, because the buyer remorse, within the insurance, you can return without paying any penalty, or the product, fails, and you have to return it. And oftentimes, the customers will return the device because the handset crashes, and they don't know what to do. So they tend to take the device, go to the retail store, return it. And oftentimes, the devices have no trouble found. It's called NTF, right? And I think in Japan we call it tested okay, TOK. And it's a very big problem in terms of what I know, in the carriers in North America, like AT&T and Verizon. The handset returns are millions of units. Not long ago we had a meeting with Verizon. They said, well, this year we are processing 18 million devices, and about 30–40% of these are no trouble found. So as I think maybe Dr. Chen said something this morning, the cost of processing the NTF is really, really big. And I agree with his assessment. I think you're going to spend $100 to $200 per NTF return. So that for AT&T or Verizon it's like $1 billion a year. So in North America, you're looking at maybe $3 to $4 billion spent on processing the NTF. Okay. So what I'd like to stretch to you is how the AI could be used, to reduce the NTF. And what we are doing is, just like KDDI presenter talked about, we are using proactive, data sampling. We put a data sampling software in each device, and then we monitor the about 40 to 60 different parameters. So every few minutes, we capture the data, and then we send the data to the call center server. And we are looking at AWS, and we are exceeding the original forecast. We are now in these 40, 50, maybe pretty soon 100 virtual servers. And that means a lot of expenses, a lot of data that's being processed. And as you know, that when you store something in AWS, it's pretty much free. But when you retrieve something from AWS, it costs you a lot of money. So this AWS cost should not be ignored. And I feel E3 here has some very interesting solutions. So that's an alternative. So if you can reduce this NTF, you have some benefits in terms of helping the call center, the efficiency, the call volume, and more importantly, the end user satisfaction is called CSAT, the user's satisfaction. You increase the satisfaction, you reduce the churn. There's a term in the US we call it churn. That is, you lose a customer. So you can minimize that churn, okay? So this is a typical example of how the AI system works. And you can see that it's a system that has a diagnostic app that collects the data. It will then send into a domain database. It's a carrier control cloud. And in this case, it could be AWS, or it could be something else. And then the other part of this AI process is reference materials. Sometimes we call it knowledge base. You got to have this large knowledge base about the handsets that you are selling, you are servicing. So this knowledge base needs to be built up. And we just gave some examples, like technical terminologies, the English or Japanese dictionaries, the local language adoption, and the integration of all the data. And the carriers with its OEM partners, usually it will create a current data base, a knowledge base, and an error code. And then the environmental information, sometimes we call it, customer service history, okay? So then the error code plus the technician's solution that's built up over years becomes a very powerful reference material for you to go into the AI engine here that looks like a brain that actually processes all the data. It will then take the data outputted to the call center technician. The technician can then fairly easily find a solution, and I will show you a little bit later on how a screen could be created and designed for the call center technician. So this is an example of a support technician AI console. And what this shows is the AI technician could take a call, and then he could retrieve the database. It would show, 11 different handsets with different IDs in the model number, and it will have some kind of error code information. And then the AI technician could click one of the windows, and that will show you what the potential solutions are. So this is a design to help the technician using the AI solution, okay? This is adaptive screen output, and this one shows that you can pick from one of the handsets. You can click on this, and will show you over the time scale, different crashes, the timing of the crashes. And then from there, you can use the AI solution based on the engram or clustering techniques. And that will give you the output so that you know how to pick, the best solution, that you can find. So this is the crust of the AI engine. And then if you're interested, we can show you how this works. As I mentioned before, our solution could become an app. You can create such an app, you load it on the handset, and this app could be used by the end users, by the individual end users, to run the AI engine, to do some self-diagnostics, to debug and minimize the return. It also will send the data to the call center if you want to call the call center. And the call center will then find out what is the solution and what is the recommendation. And also this improved efficiency. And as you know that, I'm just quoting the US cost. And typically a call to a call center takes about 15 minutes for a technician to understand and solve the problem. And then if you multiply that by the cost of a minute, in the US, typically it could be 50 cents. So 50 cents times 15 minutes times millions of calls. At the end of the day, it's hundreds of millions of dollars. And this is a common knowledge, people know, like AT&T or Verizon, they spend $200, $300 million just for the call center. And I think the problems probably are similar here, but probably not such a high magnitude. So, so this again will reduce the problem for the call center, and then you can build up a good customer satisfaction. And this is probably the most complicated slides, but I'll try to explain it to you. So we divided the AI system into 3 areas. This area to the left is the subscribers, the users, that would input data into the radio network. And from the radio network, it will go into a storage device. And then eventually it goes into this AI processing center. And it's got the ingestion machine. That is, it will take the data, it will ingest it, and it will arrange it so that it will figure out what is the best solution. Usually, the next block is an AI engine. It is provided as a service, software as a service, SaaS. So that actually does all the intelligence work. It then will output either a recommendation back to the user or to the technician what to do. If there's no solution, it might just take an input and store it in the database. So in the future, we can process it further. So this is a system that we have been doing it for a few years. And I just want to mention that this particular solution is a continued evolution. So if you are interested in this, if you're in the carrier telecom, or if you are an OEM, that you are making a lot of handsets, and for every 100 handsets, you got to ship an extra 8, just to make up for the NTF cost. You should consider the AI solution, okay? So OEMs and the carriers. And the other big cost center is the repair and refurbishing center. And you know that all these devices that are sent to the warehouse for processing, for repair, oftentimes when there is no trouble found, it costs the industry lots and lots of money. So I think by using the AI, you will reduce that, okay? So this is kind of my presentation here in a short order. So thank you for your attention. Okay.